Hey guys and gals, hey guys and gals, what is good? What is good? How you doing? How are you doing today? How are you doing today, I ask. Let's go. How are you doing today? I hope you're having a great day. Turn it up. Thank you for dropping by. Lurkers and twerkers, appreciate you. Lurkers and twerkers, and you sandwich making workers. Let's go. Let's go. Thank you for hitting the play button and watching the content. If this is not live, I do appreciate you. I do appreciate you. I wanna pump you up and get you excited to learn, guys and gals. I truly do. Running a little bit behind today, so I'm gonna try to speed things up to the best of my abilities. All right, we're gonna get right through the kind of get right to things. All right, shorten the intros a little bit, but I want you guys and gals to know, those of you, whether you're lurking or twerking, making sandwiches, which I love, and those of you that hit the play button, checking out the content, I appreciate you. Thank you for dropping by. Johnny with Whiskey Tango Sharp Coating. Appreciate your support and your views. I appreciate your support and your views. Let's go. You know it. I love it. I love it when you do that. I loves it. Truly do. I want to give YouTube some shout outs. YouTube, let's go. I say this because you guys are like going par to par, toe to toe with Twitch and the views. Turn it up. Thank you for turning up the temperature. Man, that's great. I appreciate it. Just want you to know, also want supporters, followers of the channels. You guys are great. Just throwing it out there. Yeah, I could do this, and then we're gonna get kind of right to it. Again, like I said, I'm running a bit behind. We got a bit of content to get through. So let's do this. Right on, that's it. That's right, that's right, that's right. That's my fam in the background. Great crowd, crowd in the back there. Trying to get my words out there, crowd. Let's go. Throwing it out there for you guys, supporters of the channel. Those of you that hit the play button, watch the content. It's great to have you guys and gals. Turn it up. Turn it up. All right, let's get right to it. It's time to learn. Time to learn. Let's do this. Throw on the old thinking cap, guys and gals. Let's get right to it. We're kind of, putting it in another gear, especially for today. I don't know about any other day, but today we got to get right to it. We got to get going. Those of you that are kind of watching the content, again, it's great to have you. If there's areas in the each video, I will add. I just want to add. Okay, if you're clicking and dropping by for the first time or whatever, or just joining or whichever it is, it's great to have you. 100%, absolutely is. I recommend that you kind of start from the beginning. We're going step by step here in the process of everybody's journey. Those that are watching, your journey is obviously to learn C++. Johnny here, myself. I'm going to do my best to make it easy to learn with examples and explanation. Hopefully hopefully I don't go off on too long of a tangent, but a lot of times, I'll explain things probably maybe more than I should, but I just want whoever, everybody to learn and be able to do this, right? I want to make certain that you are grasping and getting the concepts, okay? That's the main goal. Also, we're doing a lecture class over here, okay? That's what this is. If you're looking for that 5-minute video on how to write a variable, well, you found the wrong channel. Those of us over here learning and growing, we already know how to write variables, okay? Let's go. If you're watching along in that and you're, following the series, lecture series, classes series, however you want to look at it, and if there's an area that you kind of already understand, by all means, you could just kind of scroll that play slider bar forward, and I'll see you in the future. In the future. In the future. Just because it's funny, I got to do it again. Okay, so yeah, I'm here to make, yeah. Man, I don't even know what I'm trying to get at, but the main goal here is to make sure, help you guys and gals learn this coding language with ease. That's the goal. Okay, so let's get right to it. I think it's time to learn. That's enough kind of yabbering and going on. Hopefully you get the idea, but I just wanted to be clear and certain. This is a lecture. This is a course that we're following. Just to be clear. Okay, so welcome. It's great to have you. A lot of you are eager to learn, and that is great. So yeah, I just a little bit inside, I'm like, yeah, man, it's great to have you. Those of you that want to learn this and you're following along, you guys are awesome. Truly are. I mean that. All right, we're going to continue on with this. We're working on what's the area called here? Not that. Scrolling back here. Overloading functions. That's what we're doing. Function polymorphism. Okay, so if you've been following along, you already know what's up, which is great. I want to show you guys and gals an easier way. Okay, so I showed you this, which is great. I mean, we all kind of have to have this understanding and knowledge of sort of thing, right? That you have the ability to overload functions. Okay, we can do this. It is great. It is a great thing. It truly is. Okay, now you got different data types, so obviously when you do all the magic inside the main body here, the only kind of troubling part is you have to kind of each of these variables here are dedicated to a certain particular function or data type. Okay, so you can't just randomly just maybe select one of these and just put in, let's say, a float into an int. It doesn't work, right? The program's going to take in whatever information you give it, which is this, right? We could set this up as user entered information via user prompting or whatever. We could, but for all intents and purposes, this is, easy enough, just kind of the easier, quicker way to do stuff, okay? By hard coding values, right? Okay, so carrying on. So we did all this, and I'll just build it quickly, and we'll run it. And there we go. We get our output, right? Our functions are basically doubling the values of each different data type. And the program, the compiler, will go to the appropriate function and use that function based on the data type. Okay? Let me show you something that's kind of is easier. Now, I didn't mean to get into this, but I figured maybe this is a good time to do this. Okay? So what I'm going to show you is called templates. They're called templates. And do I actually have... curious about something. Let me close this. I want to actually get this done. I have to finish my mod stuff, but I'm also just trying to get things going here, guys. Bear with me, please. I want to get this one document closed so that it's kind of out of my way. Be gone. Too many things going on here. Okay, good. Closing this. All right, so I want to check here. It's called template. I want to see if I actually have that in my 154,000 character coding, C++ coding document. Really, it's not really an informational book per se, or it has information, a lot of information, but it doesn't have a lot of examples. That's the only thing. So it's more of a, let's say you forgot a certain topic and you kind of maybe forget the definition or whatever. That's kind of what this is. Something you can reflect to, just kind of refresh your memory. I want to see if I have anything on templates in this. There's a lot here of information. I've been slowly... Function template notes. Would that work? Maybe. Okay, let's just see. I'll have a look here and see if it's kind of related. I want to kind of give you an explanation what a template is before we kind of use it. Static cast operator. Man, I have to look for that. It's in my file explorer. I kind of have a note here. Where would I look for that? Good question. Let's see, documents. Let's just search in here, see if we can find it. There it is. Let's open it. There we go. Okay, that's static casting. Okay, there are templates in here. Okay. All right, it's just a bunch of examples. That's okay. Let's bring this up. I'll share this here with you. Function template notes. A function template is a pattern. Note the actual code. No actual code is generated until the function name in the template is called. The function template uses no memory. When passing a class object, okay, I'm not going to read all that. It's there if you want to kind of pause it and read it. But I want to just get right into it here. I want to simplify it, okay? I don't want to overcomplicate it. So let's make it simple. And it really is. Function, not called function templates. They're called template. What is a template? C++. Okay. All right. A C++ template is a powerful feature that enables generic programming. allowing you to write code that works with a various data type. This is the key, right? As you can see, we have various data types, guys, right? And we have we basically have 4 functions. And each function is taking in a specific data type, right? Templates make this a lot cleaner, simpler, so that you don't have to have all this. We're actually going to be deleting this, but let me show you. Allowing you to write code that works with the various data types without having to repeat the same logic for each specific type. So we're kind of doing that here, right? It essentially provides a blueprint or formula for creating generic functions or classes. Okay? There are 2 main types of templates in C. There's function templates and then class templates. Okay, we're not doing a class template, we're doing a function template. Function templates, these allow you to define a function once and then use it with different data types. The compiler generates specific versions of the function for each type it is used with. Now I'm just going to show you an example here, and I'll just paste it up here, I guess. Done with that. And then we're going to get into some recursion in that. So I wanted to kind of share this example with you because you probably, maybe you watched and you've seen this is a lot of code to kind of do. I mean, it serves its purpose, right? If you have different data types, the program will go to the corresponding function and do the calculation, right? What am I looking for? This, and I'm looking for this. Okay, so I'm just going to put it up here with global functions. Actually, I'm going to put it above it. Okay, so here's an example. This is essentially how it's written. Okay, you have this, which is always mandatory. Provide sample template arguments for IntelliSense, right? This is kind of like giving the compiler a heads up. Hey, we're using a template here. Okay, this is the actual function itself. This is an example. So I have to kind of, decipher it and break it down. Obviously, so T is kind of like the generic, most common name or character, right? So this is kind of the filler for the type. Okay, T is the type. Obviously, this is the name. And then here's the filler again. It depends on the data type you put in. So data type A, right? Whatever random type T is put in. This is these are our parameters, right? Again, variable. And another data type, whatever data type that's going to be. The T is the filler, the template, right? And then B would be another variable. And then return, this is a ternary, what you see here. We went over ternaries already. If you guys and gals have been following along, you know what that is and what it does. So there you go. That's an example. Okay, so I'm going to actually type one up that we're going to use. But I want to show you something here. We're getting rid of all of this. Okay, it's going to replace all this code. That's what it's doing. Control KC. And then I'm going to go down here. Always go too far. These are our definitions. Control KC. Okay, boom. Everything's commented. Okay. And it should still work here, right? This will be unchanged. But right now the compiler's like, I don't recognize these functions, right? Because I just commented them out, right? It doesn't know about them. So this is something great. So check it out. And this is way simpler. We're replacing all of this code here and down here with this. Let me show you. Okay, I'm going to call it a static, because why not? And it's going to be T, generic type T, our function name, double. Okay, And then it's going to take in parameters. It's going to be taking in whatever random data type that is. And then I could just use any variable. It could be anything. I could put var. I could put whatever. I could put t, confuse people even more. Okay? It's generic. And this is kind of the behind the scenes. Oh, I forgot the template part. That's kind of key. Whoops. Goodness gracious. Okay, let's actually type in. We gotta define it, right? We gotta tell the programmer, the compiler, hey, we're using a template here. Okay, there. There. Okay, it's called type name. All right, this is behind the scenes. There we go. This is key right here. This here. That's kind of telling the compiler, hey, this is a template below. Okay, this is the declaration part of it. All right. So, and then we just return, just like we did here. It's going to be the same calculation. Return 2 times whatever the input is. Okay. So just to finish up, return 2 times a, because a is the argument or parameter, right? So there, done. That's it. So this here replaced this and all of this. So I could actually delete all this. So you'll see, watch, I got to clean it up anyways. I'm going to clean up all this code. Why do I have that there? Get rid of it. Be gone. And then I'm going to get rid of all this. Okay, whoops. And if you've been following along, you would have seen that I typed all this. So I build this, right? Check it out. Look, you can see now the compiler recognizes the function. So this template here is going to do everything. So it'll take in whatever data type it is, and it'll do the same calculation for us. So check it out. Boom. Right there. Drop the yays because we can. That easy. That's the nicest thing about templates. That's templates in a nutshell, guys and gals. That's templates in a nutshell. I recommend using them so you don't have to be doing all this. Obviously, the stuff you do in the main is going to be basically the same, right? We still have the same information. We have 4 different data types. We had to this here, I mean, I could actually save all this extra redundant code and go like this, because you see a lot of duplication going on. So I'm declaring it right here in line, because we have kind of a lot of extra information which is useless. It's not really useless, but here we're actually, I guess if you want to initialize your variables, right? If that's what you wanted to do, that's what you would do here. Okay, but I'm going to delete all that. So I initialized and, well, no, I declared. Technically speaking, I'm initializing, but I don't think these are set to 0. I don't think so. I don't know. I'd have to do the debugger. Maybe it'll work and show me. Let's see. Let's have a look. Okay, oh yeah, it's showing 0 here, but I haven't stepped into it. So let's step in. We stepped over. Okay, it's already got a value right there. I can't really step back. Let's have a look here. It's saying 0. So I don't know. It initialized it under the hood in the background, even though I'm not really initializing here. You know what I'm saying, guys and gals? Right? So if I step over again, this should actually have the value. See, it already did the calculation. It's already done. You can see the values are already stored. And then I'll step over again. Same thing. and step over again. And then I can actually step into the type T, right? We're going to stop that. Make sure my console is closed. Okay, so that's the only reason I did that is because, I know if I do this, I know 100% that if I actually can type properly, I know 100% that I've initialized this variable. This variable is created for our function, okay? If you've been following along, you'll understand why we create these extra variables and what the reason is behind that. If you don't, I recommend you go back a few videos and check it out so that you can kind of be up to par with all of us learning here. Okay? So for all intents and purposes, all I did by getting rid of this is I'm declaring, and it's not showing me the initialization, right? So, but the right hand side is our function, right? It's equal to our function. I'm going to leave it at that. That's it. Okay. We haven't initialized, but when I ran it, apparently it has the value 0 given to it, which is great. Okay. You don't want garbage. You don't want your variables to be garbage. As a coder, it's kind of like your contract to make sure that whatever end user is using your program or application, that it's not returning garbage information, right? It's in your contract. As a coder, it's your responsibility to make sure it has some sort of value. Okay. So just to be clear. All right, that's it. That's template in a nutshell. Simple. Look how clean that is. That's one function. Wow, this is the function. Okay, this is the template. This is telling the program, hey, this is a template below. Okay, it's nice and clean. Okay, so I'm going to clean things up. We are done. We're done with this, and we're going to get into... We got a lot to do here, so lots to learn, guys and gals. So I need to kind of keep things going. Did I read? We're going to get into inline functions. What does an inline function do? They kind of have their own, they serve a purpose as well. Okay, everything's cleaned up. Today's topic, we're going to be doing inline functions, and then we're going to get into recursion. Okay, there's a few examples I want to show, and I want to try to keep the content within a couple of hours. So recursion could take a little bit of time. It's almost a video on its own, to be honest. Okay, special topics about functions. Again, it's great to have you guys and gals, those of you that are watching and learning. Thank you for the patience with me, doing my best to be an instructor, someone positive in your life to help you learn. So thank you. Thank you for your understanding and your patience. It's great to have you. Okay, because functions are so central to programming, a few special topics arise that might be of interest. When you confront unusual problems, used wisely, okay, don't worry about if you come across problems. That's the thing about coding. You're always going to come across something, right? And the great thing about it builds that, I don't know what kind of skill set you could code. I'm sure there's a name or a term for it, but you build kind of a skill set where you're working through a problem and you're becoming a problem solver, which is great. It's actually a good attribute, quality, right? I'm sure that's a course on its own too, or as well. Okay, recursion. Okay, so there we go. These are today's topics. Okay, I'm we should have a clean program. It's just going to run all the random normal stuff. Okay? Used wisely, inline functions can help you squeak out that last bit of performance. Remember, right here, right? The key things about, well, just programs in general, memory, performance, and optimization, especially with C++. You learn how to be a really solid memory manager because all the other languages are managed languages, okay? With C++, you actually have to become your own housekeeper. And I like it. I have no issues doing these sort of things. It's great. Okay, I have no issues or problems or qualms with doing these sort of things. I actually enjoy it. So, but yeah, you have to manage your memory with C++. And because of it, you get to learn and have a stronger, better understanding of what happens under the hood. Okay, I think by far it teaches you a lot more than any other language can. If you begin with C++, I support you in your journey. If you begin with C++, every other language is going to be easy to learn after. Trust me on that, guys, gals. It's going to be way easier. You can't start from the easy stuff and expect to learn C++. Okay? I recommend you just suck it up. I'm being nice here. And C++ is something you want to learn. If you get it, once you get it, everything else is going to be easy. It's going to be gravy on your potatoes, I'm telling you. Okay. Function, so yeah, performance, right? That's what it's about. Memory, performance, and optimization is kind of the last thing. You can optimize your code too. Just do little things with your code to, help it perform better. It's kind of like compiler or code line by line fluidity, if you will. Okay, let's continue. Function recursion is one of those wonderful esoteric bits of programming which every once in a while can cut through a thorny problem otherwise not easily solved. Okay? Don't worry about that too much, all right? Don't let the challenging, just because somebody said the word hard doesn't mean it's hard. Okay? Right? What's the saying? It may be hard for them, but it's not hard for you. Inline functions. When you define a function, normally the compiler creates just one set of instructions in memory. Okay? When you call the function, execution of the program jumps to those instructions, right? Line by line until it reaches a function, blah, blah, blah. And when the function returns, execution jumps back to the next line in the calling function, right? Right? If you've been following along, you'll understand line by line till it reaches a function. That's what's happening here. It runs through all this, right, in the main. And then it'll get to the function. This is, calling our function or invoking it. It jumps to this, right? It jumps inside, and then it runs this block of code. And then when it's done running that block of code, which is it's really fast, like CPUs are like Lamborghinis, if you will. And then once it's done, it jumps back. It basically, I imagine, jumps right to this line, even skips this, just goes right to the end because there's nothing else happening after, right? It continues on. That's what it does. Okay, until it reaches here. That's the end of the program right there. Okay? Beginning, end. Out of scope. LIFO. LIFO, my best, just kind of before we even get into memory and talking about memory, think of a stack of library books. Okay, you have them on your desk or whatever, or on a table or something. It's a stack of books. Let's say it's a stack of 10. It could be any number. LIFO basically, when it gets to here, it deallocates, it cleans up the memory. Okay, it kind of maybe throws in garbage. I don't know what it does under the hood, but it kind of erases the memory that you had there. It gives it it gives it to the back to the CPU, essentially, to the processor. It says, "Hey, processor, here you go. You got this space again that you could use." It's just memory reallocates memory so that it could be used again. Is what it's doing. So it's cleaning things up so that memory spot or location could be utilized again in code or whatever you're running, right? So the library books, okay? So when it deallocates or cleans up the memory, it starts from the top of the stack. This is the term stack, right? And we'll get into, like, stack is kind of, you have kind of, there's two kinds of memory, stack and heap. Heap is kind of the live running dynamic memory allocation. Stack is kind of before all that, before you even run. It's just memory allocated before, sort of thing. Stack is the first thing you need to learn anyways in regards to memory. So the stack of books. So when it deallocates, it takes from the top of the stack, okay? And it goes backwards, essentially. So when it's cleaning up memory, it actually goes backwards, okay? Because that's the last in, first out concept, okay? Think of it like that. Top of the stack to the bottom. Last in, first out. That's what it is, LIFO. I know I have this in my notes somewhere in my 150,000 character document, but I'm trying to speed things up here, and we have a lot to go through. Okay, let's continue. Where were we? So it jumps back to the next line in the calling function. If you can call the function 10 times, your program jumps to the same set of instructions each time. So what that means is, if I actually called this, right, I could go crazy. I could, what the hey for horses? What the hey for, hey, well, let's go, bling bling. Let's go. Don't mind me, I'm just trying to go wild here with the copy and paste. Let's go, turn it up. Appreciate you hitting the bling bling. I got the notification. Thank you for the follow. Let's go, turn it up for Kenny M. Kenny M. Gassy. Let's go, Kenny. Thank you, brother. Appreciate the support. Much love for that. I'm going to continue on. If you don't mind, I get distracted easy, and I got to get back on the railroad tracks here and keep teaching this because I'm enjoying doing this. It's great to have you. It truly is. It means a lot. It truly does. I'm doing this for you guys and gals. I'm enjoying doing this. And I feel like I got to keep going. I want to keep going. I want to keep this train going and keep helping you guys learn and grow. Okay? So I'm calling this function a whole bunch of times, as you can see, right? So if you think about it, when the compiler runs, it has to jump in. It has to go back here, and then it jumps back here, and then it goes 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 back here, then it goes back here, then it goes back. You know what I mean? You get the idea, right? That's a lot of jumping back and forth. Okay? I'm just going to undo all that because I don't know what I was doing there in memory. I find it best to just undo instead of just building and erasing things. Because, things can get messed up pretty quick. So undo is the best solution if you want to get rid of anything you don't want. All right, let's continue. So let's say we called that function 10 times. Your program jumps to the same set of instructions each time, right? That makes sense? This means only one copy of the function exists, not 10. Okay, a small performance overhead occurs in jumping in and out of functions. Okay, So again, that's the big thing. It's about performance and speed, right? With programs and software, right? It's huge. I mean, it's important, right? So it turns out that some functions are very small, just a line or two of code, right? I mean, we got a few lines of code here. We're just spitting out couts. That's all it is, string literals. Nothing special about it. Okay, so, oh yeah, I gotta update that. Let's go, Kenny. Okay, I'm dropping the ball here a little bit. I don't mean to. Kenny, let's go. I want to show the love this time. I'm gonna have to just type it out. Okay, I need to update. I have to remind myself to do these sort of things. Kenny M. Gassé. It's not gassy, it's gas, but anyways, I don't want to ruin your name. Kenny, it's awesome to have you. All right, let's go. Let's build that and run that for the first time. Let's go, turn it up. Drop the yays. Yeah, much love. Thank you for the support. It's great to have you. I mean that. Just create a little space there. Okay. Let us continue. I might end up having to continue recursion. How far are we into time here? Not bad. We still got a good hour. Okay. So I'm trying to speed things up, guys. Okay. So it turns out that some functions are very small, just a line or two of code, and efficiency might be gained if the program can avoid making these jumps, right? So you're going to use inline essentially if you're going to be calling the same function a whole bunch of times in your code. Okay, that's what inline functions, the purpose that they serve. Okay. Let's see, where am I in the readings here? Might be gained if the program can avoid making these jumps just to execute one or two instructions, right? When programmers speak of efficiency, they usually mean speed, right? The program runs faster if the function can be avoided. Okay, right? Makes sense? It'll run, we're talking milliseconds or whatever it is, but humans, really, we don't have a lot of patience, do we? You guys are lucky nowadays. Can you imagine if you had dial-up? Takes like literally 2 minutes to load the first page, the first internet page. Yeah. It's the pain that a lot of people had to kind of endure back in the early internet days. Dial-up modems. Turn that up. Okay. I gotta continue because as much as I want to talk about the dial-up modems, I gotta continue. All right, let's do this because that was kind of funny. I almost wanted to search for a dial-up modem sound. Almost. It was close, guys. It was close. I'm telling you. I must resist. Okay, if a function is declared with the keyword inline, okay, up here I have it, this is declared as static, okay, that's something entirely different, but inline, right? So I could type inline if I was to call this function a whole bunch of times, okay, that's what you would type. All right. We'll do a sample function here. Imagine I have something here I could type up. I want to finish this reading. The compiler does not create a real function. It copies the code from the inline function directly into the calling function. No jump is made. It is just as if you had written the statements of the function right into the calling function. Okay, if that makes kind of any sense. This is kind of under the hood stuff a little bit. Okay, the calling function, right? The first function would be the calling function, right? Essentially, the very first one. Okay, again. No jump is made. It is just as if you had written the statements of the function right into the calling function. Okay, note that inline functions can bring a heavy cost. Okay, if the function is called 10 times, the inline code is copied into the calling functions each of those 10 times. Okay, right? So before it kind of just jumped back and forth, there was no copying, right? The tiny improvement in speed you might achieve might be more than swamped by the increase in size of the executable program, which might in fact actually slow the program. Okay, so this is part of the theory, guys and gals, things to know, right? Be aware of, right? Again, if you're learning this language, I recommend take notes, whatever you have to do, whatever helps you learn, right? All the repetition and going over, do the review and stuff. Repetition, 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 guys and gals. Okay, that's how we learn. Okay, so the tiny improvement in speed you might achieve might be more than swamped by the increase in size of the right? The increase in the size of the executable program, right? Because more copies, bits and bytes, guys, bits and bytes, right? More copies being made, obviously something is going to increase in size, right? The executable is an actual file, right? Whenever you run a program, it's the executable that you're running, which might, in fact, actually slow the program. Okay, the reality is that today's optimizing compilers can almost certainly do a better job of making this decision than you can. And so it is generally a good idea not to declare a function inline unless it is only one or two at most statements in length. So what it means is this, right? One or two statements. Okay, if this was an inline function, right? Let's say it's doing whatever. It could be anything, a calculation, it could be anything, right? So, just to be clear, it is generally a good idea not to declare a function inline unless it is only one or two at most statements in length. When in doubt, though, leave inline out. Okay? If in doubt, just leave it out. That kind of rhymes, right? If in doubt, just leave it out. Also, another tip, guys and gals, if it works, don't touch it. Don't change it. Leave it alone. If it works, don't break it. Okay? You can't make something better if it already is good or better. Right? That's a tip for you. Performance optimization is a difficult challenge, and most programmers are not good at identifying the location of performance problems in their programs without help. There are little things, little nuances you could do in code, maybe outputting information or something in specific areas of your code to figure out where things are slower or faster. There are ways. There's also, there's other ways, and also you can just trying to think of something off the top of my head here. Where do I have that in code? Goodness gracious, I don't even know, to be honest. let's see if I can find it. Something multi-threading, that's what it was. Yeah, using chrono, the chrono include, and I'll try to show an example to you guys and gals in the future. There's so much I can share with you guys and gals. It's insane. I love this stuff, right? Using the auto stop time, high resolution clock, and you can figure out the duration or how long a program runs, right? You can spit that out in code as well. I'll show you an example in the future. Okay, in the future. Okay. Most programmers are not good at identifying the location of performance problems in their programs without help, right? Maybe help from others or help with doing little things inside your code to try to figure out where things are kind of slowing down. In this case, involves specialized programs like debuggers and profilers. Also, it is always better to write code that is clear and understandable than to write code that contains your guess about what will run fast or slow, but is harder to understand. This is because it is easier to make understandable code run faster, okay? Again, don't be a copy and paste coder, okay? There's nothing wrong with seeing other people's code and learning from others. There's a lot of great coders out there in the old interweb. There's a lot of good support, helpful information, what other things, forums, those kind of things. Again, you have to decipher which is good and which is bad. You have to take the good with the right. You're gonna have to be able to make that decision. Is this good code or is it bad code, right? And so, but again, there's nothing wrong with learning from others, seeing other people's code, and it's up to you if you want to use it or not. You can try it, you can test it. If you don't like it, scrap it, sort of thing. There's so many different ways to write code. There really is. Okay, let's do that. Let's write some code. Everything's cleaned up here. I got to get rid of this. Okay. Let's see. Whoop. Okay, don't do that. Don't do that. Okay, we're good. All right, I just wanted to make sure I was at the last spot that I made any changes. We're okay. Perfect. Okay, so we're going to do a little inline. Actually, I was using this function already. I got it backed up in code. So I could go like this. Which one am I using here? I'm using the int one, the int double. Int double. So I'll just copy this. And then I'll just paste it back down here. And then Control KU to get rid of the commenting out. And then I'm going to go like this. And I'm going to go back up to the top here and do this. There we go. That's done. So we're basically reusing the last bit of code, but we're only using one of them. I could use the template, but it doesn't matter. For all intents and purposes, actually, why would I use the template? We don't need that right now. So we're just using one of our functions from the last example, okay? So we've declared, we've done our definition, that's done. So now what we need to do is go into our main here and create a new variable. And we're going to call it target. Good enough. I'm going to initialize it to 0. There we go. Done. Okay, that easy. So we're going to get the user to enter a value. Okay, let's do that. User prompt is what I call it. And enter a number to, enter an integer number. Okay, I'm just gonna go like that, and I could go user please, something like that. Again, you're the coder, You're the one writing the lines of code. It's up to you what you want to use, okay? You're the creator, right? Use your magic and your mind. All right, there we go. Now we have to actually put that value. The user enters a value in the console, and now we actually have to store that value. There we go, okay? And I could do a couple of things here. If I need an end line, I could go like this, and then just put a single new line. There we go, done. Okay, and then we have our new variable, okay, which is going to it's going to accept our function. Hold up. Oh yes, we're kind of doing recursion a little bit. This is kind of neat. So we're going to take our function, which is double, and then we're actually, so it's kind of wild sauce. Check this out. It blows your mind a little bit. It does. So we've created a variable that's for storing the value that is received from our function. Okay, but we're also going to be using it as our argument. I know. This is part of the recursion, right? The mind-blowing stuff. Kind of messes with your brain a little bit, but it works. Okay, target. And then we're going to return that value. There we go. And then I'll just copy this. There we go. And then we're going to do this. We're going to do this, I don't know, 1, 2, 3 times. Okay, so I'm just going to copy the exact same thing. As a matter of fact, let's just run it once to see what happens. So whatever the user enters for a value, basically it's going to be doubled. Okay, again, the variable here doesn't need to match what's up here. This is kind of, think of it like a neighbor. Okay, this is a fence. Okay, this is its own neighbor, and this is its own neighbor. Okay, the variables can be different. You can't have them the same, but for myself, I like to have my variables with different names. But if you want to utilize the local global stuff more, that's up to you. Okay, so I'm going to run it once, and it's just going to double our value. That's all that's happening. Let's build it. Let's run it. Okay, so I'm going to enter the value 20. Okay, let's begin with that. Boom. Boom. Let's go. That's so nice. Just hold up. I want to drop the yays because, you know, I like doing that. Let's go. Okay, so I didn't write integer properly. That's awesome. Yeah, I'm a really gooder typer, guys. A really gooder typer. Let's go. Okay, so what we've done here is, man, it's pretty cool, huh? So we've taken that integer, okay? So we've taken that value, the user entered value. It gets put in, this is our argument, right? It gets calculated, boom, doubled basically. What do I have here? Okay, I don't need this extra redundancy. You guys know that we're going in here. That's good enough. Lessen the confusion. Okay, and then it gets stored back into the same variable. Okay, we're kind of using, we're reutilising the same variable to accept that new value, right? So, right, guys, understand what's happening in memory line by line. When the value gets doubled, initially it was 20 here. It gets doubled, then it gets restored. Okay, that's what's happening under the hood. So the compiler, however you want to look at it, is going to spit that information back out to us. And that's through this line of code. And so it's only going to spit out, I use the word spit out loosely, return to us, return to the user, display on the screen, however you want to look at it, right? It all means the same thing. Okay? It's going to print out the most recent stored value in memory, okay, which is this. So that's what's happening. So I'll run it again. It's storing it. It's going to store it. It's going to double it, and then it's going to restore it. And boom, there we go, doubled. Okay, and let's go again. So this is part of the recursion a little bit, right? We're reusing the code in the sense. What's happening is the recursion is kind of happening through the variable itself. All right, so I'm going to build that. It's storing it, and then it's getting restored. And then we're going to see the exact same thing. So check it out. Check this out. Okay, I'm going to enter 20 again. Boom. 40. Again, so what it's going to do in memory, guys, under the hood, it's going to take that value 40. The new value for target is 40 in memory. And then it actually reuses that value here, puts it in. It gets doubled. Boom. Restored. It becomes 80 now. Okay? So in memory, this is all the under the hood understanding, guys and gals. Okay? This is cool. I'm all excited. I don't know. It's kind of wild. All right? I love this stuff. Okay, so then it takes that value 80. Again, it's going to use the most recent last stored value in memory. Okay, that's what it's doing. Boom, stored, it's 80, gets doubled, boom, becomes target. Target is now 160, spits out 160 right here. That's what's happening under the hood in a nutshell, guys. That's it right there. Okay, that's a demonstration of, I didn't even type inline. I was supposed to do that. My bad. We'll run it again. It still worked. Okay. You guys are like wondering, well, when do you use inline? I was all excited and in my haste to, show you the example, I forgot to do that part. Okay, so let's run it again. It's going to be the same thing. It doesn't matter if I go like this. Build it. We'll do it. We'll start again. 20. Boom. Okay. 40. All right. Same thing. Control V. Build. Same thing. Run again. No difference. Okay. There's no difference. Okay. So the inline part. Okay. What does it do? Right. Inline functions can bring a heavy cost if the function is called 10 times. The inline code is copied into the calling functions each of those 10 times. But again, guys, this is just one line of code, right? So using inline in this sense, you shouldn't have to worry. It's not going to be an issue. Okay, it's supposed to actually speed things up. Okay, again, 1 or 2 lines of code. We're just returning a value. That's all we're doing. Okay, and we're avoiding all the jumping back and forth. Okay, that's what we're avoiding doing. All the jumping back and forth, right? In a nutshell. When you define a function, normally the compiler creates just one set of instructions in memory. When you call the function, execution of the program jumps, okay? All right. When you call the function, execution of the program jumps to those instructions, and when the function returns, execution jumps back to the next line in the calling function, right? right? Again, this is the new calling function, right? That's how it's working, right? We're calling it here, we're calling it here, we're calling it here, right? We're repeating the calling. Okay, if you call the function 10 times, your program jumps to the same set of instructions each time. This means only one copy of the function exists, right? So what they're saying is that's without using inline, okay? What I'm saying there, that's without using inline, right? No copies because it keeps jumping back into here, going back, jumping back into here. Actually, this one, my bad. Going back into here, right? A small performance overhead occurs in jumping in and out, right? Let me find that inline. If a function is declared with the keyword inline, right? Okay, we're just kind of we're going over it again so that we can actually, store all this good information in our minds. Okay. If a function is declared with the keyword inline, the compiler does not create a real function. It copies the code from the inline function directly into the calling function. Okay, so it's basically going boom, 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 boom. It only goes down here once. It goes down here for the initial call, right? It goes down here for the initial call, and then it just kind of goes boom, boom after that. All right, under the hood. No jump is made. It is just as if you had written the statements of the function right into the calling function. There you guys go. Okay, that's inline functions in a nutshell. Okay. Just give me a sec, guys and gals. I gotta do something quickly. Sit back, relax, enjoy the music. I'm gonna turn it up here. But just give me a sec, okay? Let's go like this. I'll be quick. Right here. This. All right, guys and gals, thank you for your patience. I appreciate it. Much love. Thank you for the support. Those of you guys dropping by, I'm working on being a better, I guess streamer slash teacher slash instructor. So bear with me. It's kind of a growing pains, learning curve. Um, but in all honesty, like you guys, brothers, sisters, thank you for the support. It means a lot. It truly does. You guys keep me going. Also, I enjoy helping you guys learn and grow. So it's a win-win for all of us here, and I love it. It's great to have you. It truly is. Thank you, Kenny, for hitting the follow on the live stream. Much love, brother. Much love. Thank you for the support. It's great to have you. It's great to have you. Okay, let's go. Time to continue on. We're good. You can hear me. Double check the stream just to make sure. Okay. All right. Awesome sauceum. Quick drink of coffee. Beautiful. Okay. So that is inline functions in a nutshell. Now we're going to get into recursion. I'm going to clean things up. Again, remember, guys, gals, if you want to use inline functions in your code, just remember 1 or 2 lines. That's it. Or one or two statements. Okay, that's your guideline. Okay. Let's see. I'm looking for that saying again. When in doubt, though, leave inline out, right? The reality is that today's optimizing compilers can almost certainly do a better job of making this decision than you can. And so it is generally, a good idea not to declare a function inline unless it is only one or at most 2 statements in length. Again, when in doubt, leave inline out. Okay, there we go. Let's continue. Recursion. Recursion. What is recursion? What is recursion? Let's. Do I have a definition? I'll see if I can find something quickly on the old interweb. Let's see. Hang on. Recursion. Here we go. Recursion. What? I'll just actually. I'm doing this because I'm hoping it speeds things up here. Did I type that right? No, I didn't type it correctly. Okay, there we go. Okay. Recursion in C++ is a programming technique where a function calls itself. Okay, guys? Now, the first one in line, what we were doing was we were using the same variable in code twice. We're using the variable to accept user information. The value gets stored into that variable, and then we actually used it as an argument in our function, right? So the inline, again, the recursion kind of was with the variable, okay? Right? Just as a reminder. Okay, now we're talking, sorry, I meant the inline. Kind of getting ahead of myself. The inline function, we were doing the recursion with the variable. Okay, but recursion in C++ is a programming technique where a function calls itself either directly or indirectly to solve a problem. It's an alternative to iteration using loops, right? Because it actually is. And is particularly well suited for problems that can be broken down into smaller similar subproblems. Key components of recursion, you have base case. This is the termination condition of the recursion. We'll have to do examples. I don't want to kind of lose you with theory too much. And then we have recursive case. This is where the function calls itself with modified arguments, typically moving closer to the base case. Okay, that's just lingo. An example would be like factorial, right? If you weren't sleeping in mathematics class, statistics, right? It's not for everybody, but there's a lot of people that enjoy probability and statistics and those sort of things, right? I believe factorial was part of it, right? The exclamation point on your calculator. Okay, so we're going to get into an example. I was thinking of showing you the example that's kind of in this. It's called the Fibonacci problem, which the way this problem's set up, I think might be more confusing. So I'm going to begin with some other examples just to kind of simplify it. And I think next stream, we'll get it. I'll show you the Fibonacci sequence. Okay, so stay tuned. Again, it's great to have you. A function can call itself. Okay, that's recursion. This is called recursion. I'm repeating myself. And recursion can be direct or indirect. It is direct when a function calls itself. Okay. It is indirect recursion when a function calls another function that then calls the first function. You can have functions inside of a function, guys and gals. You can. Okay, I do it even in my own code, programs I'm doing. I'm almost done, actually, the program that I've been working on, and I'm going to share it with you guys and gals very soon. So stay tuned. Okay, so to continue. Some problems are most easily solved by recursion, usually those in which you act on data and then act in the same way on the result. To be clear, guys and gals, all the things that we're learning through the lecture and the course outline, just to kind of organize it in your mind and to ease your how the saying goes, to ease your mind, right? Everything that's being shown, these are kind of like the tools in your toolbox. Okay, you don't need to use everything. Okay, certain tools have certain specific tasks, right, in your toolbox. You're not going to use a hammer if you need a pair of pliers. You know what I'm saying? So you can know about the hammer, you can know about the pliers. It's just a matter of, depending on what you're doing in your task, you could either use the pliers or you could use the hammer, right? Make sense? Again, this is all part of the learning and the understanding. You have to be known. It's really weird to even say that, to be known of something, right? To understand the concept, just to be shown the concept. That's what I'm trying to get at. I know, hopefully that made sense, right? It's good to know about it. Whether you use it or not, it's another story, right? Okay. Both types of recursion, direct and indirect, come in two varieties. Those that eventually end and produce an answer, and those that never end and produce a runtime failure. So yeah, you got to be careful of that, guys. You could have, it's kind of like the endless loop theory, right? And you can have that. And it's a little bit scary if you run your compiler and all you see is like numbers just being randomly spewed onto your screen, right? Oh no, the humanity! Okay, no running around tripping over your shoelaces when you're not wearing shoes. Okay, guys and gals, be careful of that. I don't want you to get injured. Because you're tripping over your shoelaces even though you're not wearing shoes. All right, let's continue. Programmers think that the latter is quite funny when it happens to someone, right? They do laugh. I'm sure it happens to every programmer as they're learning. Let's test this. It is important. Okay, the latter is the part where you produce a runtime failure. Okay, that was the latter. It's funny. You get a good laugh when it happens to somebody. Okay, it is important to note that when a function calls itself, a new copy of that function is run. The local variables in the second version are independent of the local variables in the first. Okay, now we're kind of leading into this, right? Making copies of variables and all those sort of things. We're leading up to it. You don't want to make copies. Copies are bad. Okay, it's just doubling your information. It's doubling the workload. Okay, the local variables in the second version are in okay, and they cannot affect one another directly any more than the local function variables. In main can affect the local variables in any function. So what they mean is, if you have variables in the main and variables in the function, they're independent of each other. They don't affect each other, right? That's kind of what they're trying to get at. Okay, let's get into an example. We're kind of I'm leading into the Fibonacci stuff, but I think I'll do that next stream, because we're kind of getting up there in time. I'm trying to keep it at a couple of hours here for you guys and gals. And again, you're just getting more tools in your coding tool chest. That's what we're doing here. How does Fibonacci work? We're going to worry about that later. Let's get into an easy example of recursion. Okay, something simple. Okay, so just like I was explaining earlier, the factorial that's on your calculator, right? All right, do I need to, I'm going to create, so I'm going to start with, I'm just going to begin with, let's start creating a prototype. Okay. So, all right, int. We're just going to call it, I don't know, factorial foo. Okay, because why not? And close, and it's going to accept an int. All right. So I'm just, again, it's an int function, and it's going to take in an int for a parameter. All right. So now let's make the definition and give it a name. Let's call it n. Okay, good enough. Simple variable. We can use variables or a variable name. Okay, it's up to you. Again, as the coder, you're the one that creates these. You're the inventor of the variables. N factorial, that's common, right? N factorial, it looks like this. N factorial. All right. So let's do the body. If n is greater than, now what is going on today? If n is greater than 1, so now we're kind of getting into if statements. I have gone over if and else ifs, right? I'm doing my test condition right now. We're comparing. Okay, is n, if n, whatever is entered, whatever value is entered, if that value is greater than 1, do this. Okay? I always use curly brackets with my if-else's. There are various ways that people do this. There's this kind of style. It looks like this. Like that. It's just a different style people use. You might see it in the industry. I have a different style. Again, you pick a style and be consistent, guys and gals, okay? Be consistent. Always be consistent with your code. Okay, however you type it out, it's up to you. Now, if you're planning on working for a company or an industry or whatever, you might have to follow their standards and styles. Okay, you might have to break your own style in order to follow their style. You know, I guess if you want that paycheck, you know, you're gonna have to suck it up, right? It is what it is. But if you're doing this for fun, or you want to be an indie developer or whatever, pick a style, okay, and just continue. This is my style. It uses up more lines, but that's okay. So again, an int, it's an int function. It's going to take a return type. Remember, these are return type functions. We're going to return n times. And here's the recursion part. We're actually reusing the same function name in itself. N minus 1. Okay? And it's, so whatever value is returned, and if n is greater than 1, it's going to put that value in here. It's going to do its thing, and then it's going to multiply it by n and return that value. Okay? Else, we're just going to return, I don't know, 1, I guess. Could be negative 1. A lot of times you'll see either 0. You want to return something if it breaks, right? Sometimes you'll see negative 1. Okay, I don't know if negative 1 is the right answer, but we'll just put it there anyways. Okay, there we go. So there's our function. Done. So up in here, now we're back in our main. Okay, so we have our function, our int, our return type function completed. It's done. Done. Now we're up in our main. We're going to create a couple of variables. I'm just going to go n value, and I'm going to make it 0. And we need another variable to accept our function. Whatever value is being returned to us. Remember, right-hand side, left-hand side, right-hand side stuff, guys and gals. The function is returning a value, yes, but it's technically speaking a temporary value, okay, in memory. Right? If you've been following the series, you know exactly what I'm talking about. Man, I appreciate you following the series. I truly do. I'm moving forward. For those that are watching the series, I'm going to keep this train going forward instead of repeating stuff that I've already repeated. I might go over some stuff here and there, again, just as a refresher, but re-explaining things. We're keeping this train going. Again, if you want to learn the language, and I 100% support you in this, your I don't want to call it a dream, but your desire to learn this language, I 100% support you. And if you have any questions, answers, whatever, I'm here to help. Okay, I'm going to do my best to answer. I'll even do research if I need to. All right, so we need a variable that's going to accept the value that comes from our function. Okay, so we're going to call it result foo, because why not? All right, there. Created two variables. In our main, let's do some standard cout stuff. We're going to get the user. This is a user prompt. Okay, enter. Yeah, this is good. User, please enter a non-negative integer. Okay, hopefully you weren't sleeping in mathematics class. You know what an integer is. Non-negative. Okay, and then we got to store that value into our variable, which is going to be our end value, right? This is what we're going to pass as our argument. Okay, that's what this variable is for. Passing it as an argument. Okay, so here's what's going to accept the result of our function, and it's called factorial foo. And now we have to pass in our argument, right? Here it accepts. These are our parameters. It accepts an argument. It accepts an argument. Okay? User entered value, we're going to pass it in. Okay? All the magic that happens on the right-hand side is going to be a temporary value in memory. It needs to be stored somewhere. That's what this variable is doing. Okay? Now let's return to the user that value, right? We need to see the results of our hard work. Okay, so factorial of this is a good example. That's why I'm using it. So we can actually return whatever value the user entered, right? We could put that to the screen. It's stored in memory. It has its own memory address. It has its own container, right? Again, the die, whatever the die is inside that container. If you've been following the series, you know what I mean by the die and the container. And then we're going to say equals to this. Whoops. I just cut it. But there we go. Okay. These belong together. And then that's it. That is it. Do I need a new line? An enter? I got a double enter here, so I should be okay. All right. So let's run our program. If we actually run it on our calculator, I'm going to put in the value 4. Okay, 4. 4 factorial. Now I got to look for it on my calculator. I'm using a old school TI 83 plus. I love it. She's my baby. I owned a Sharp back in the days too, but you know, X's. You lose stuff with X's. Factorial, where are you? Factorial. I don't do much factorial stuff with this calculator. I have the common stuff, x to the negative 1, x squared, sine cos 10, common stuff, pi. I don't see a factorial on here. I'd have to use like a high school scientific. I'm sure it's in here somewhere, but I don't want to waste a lot of time looking for it. Okay. How does factorial work? Okay, just in case you're wondering, right? Just as a refresher. A factorial calculates the product of a number and all positive integers less than it down to 1. Okay, so for example, If I do 5 factorial, what that means is 5, and we're going backwards all the way to 1. 5 times 4 times 3 times 2 times 1. So if I do 4 factorial, it'll be 4 times 3 times 2 times 1. Well, you don't really need to put the 1. But I should get 24. Okay? If I run it. Boom. Let's go! Oh, do I have a negative? Why do I have a negative? Oh, that must be a code error. Has to be. Let's drop this. Typo. Okay, that's how factorial works, guys and gals. Okay, do I have a negative in there? What is up? Where is the negative coming from? Oh. The 4, okay. Where did that negative sign come from? Negative 24, which is not true. We entered a positive value, but we're getting some... Let's see. It has nothing to do with this, because that would just return 1, right? If it went into the else statement. Strange. Now it's okay. All right, that's odd. Okay, at least we're getting a positive value now. Okay, note to self: don't put negative 1 here in the return. How that even worked is beyond me. Because it's an either or thing. Okay, this is true. Because 4 is greater than 1. Okay, so it should only go into here. I don't know why that's just odd, but that's okay. Little bugs in the code. Quick fix. Okay, so if I run it again, 5 factorial. Right? That means 5 times 4 times 3 times 2. We don't need to do the times 1 because any number times 1 is the same result, right? And we should get 120. Boom. Beautiful. And that's simply the code behind for factorial on your calculator. I'm certain of it. It's that simple. That simple. So now you have an understanding what factorial is. Again, I'm just going to get rid of this. So if we did 3 factorial, it would just mean 3 times 2 times 1. The factorial of 0 is defined as 1, right? You'll learn that in mathematics, right? So remember that. It's like an n to the power type thing. Okay, n to the power of 0 is 1, right? Mathematics 101 stuff. It's a special case. It's defined as 1. Okay? So just accept the answer and don't try to change it because it is what it is. So many people. I don't want to go down that road. Always trying to change things. Just find the way we're learning things in the world. Okay. So do I have another example? Let's see. We'll give you another example, but that's it, right? Look at it, right? Recursion. We're using the same function inside itself. Same name. In this case, it's got a different process going on, right? So it's going to take n minus 1, then it becomes 3. Then it goes 3 times, and continues. Yeah, 3 times 3, right? It's all the math behind it, right? Let's see. Do we have another example? We could do the same thing with... let's see. We're going to do... I'll show you an example of base case. I didn't want to get into the theory too much because I think if I just... I don't want to... Like, I do love sharing the theory. I do. But I also, on the other hand, don't really want to just... I want to keep you motivated, right? I want to keep you learning and growing, right? And it's best to just kind of see the examples and then just go over the theory afterwards, that'll actually solidify, right? Make things better in the mind. So that's one example of recursion. Let's do another one. We could do one with string. We could do with a string if we wanted to. So as an example, we're going to do just a basic void function, no return, and we're just going to print a string. Okay? Print a string foo, and then I'm just going to, since I'm here, I'm already going to do this. I'm doing a definition right now. It's going to actually accept an int, and void functions can accept a value. Okay? Actually, we had just and before, didn't we, in this code? Okay? Yes, it can, because there's no calculation really going on. Maybe a little bit, but not really anything mathematical. We can still return that value, whatever's put in, to the user. It's just a value being printed to the screen. That's all it is. Okay, here we go. Base case. Okay. I brought up the wordage base case, right? Here's an example. If n is equal to, remember inside our test condition is when you use the double equals, okay? This is when they're used, okay? Inside our test conditions. It means if n is equal to 0, return 0. And I don't really need any brackets for this because it's just if the value is 0, it's just going to return. It's going to go nowhere. Okay, it's going to go back to the console and just kind of end it, right? It goes out of the function. It returns. It leaves the function. Essentially, that's what's happening. Okay, so I'm going to go hello, and we're going to say hello to Kenny. If I could type properly. Hello, Kenny. Welcome. There. And I'll just go like this. I always like to use these inside, especially with for loops. Very important. Okay, here's the recursion part. Oh, actually, it's wanting me to... Does it want to be static? Probably, yeah. So I'm going to go like this. I forgot the one other thing we need to do. The important step. And that is to do this. Okay, again, we're making copies. I'm passing by value right now, guys and gals. Just so you know. Okay. There we go. Whoops. Wrong symbol. There we go. Semicolon. Okay, we should be good. We have our declaration. Oh, static. So just to get rid of that other little 3-line it's a recommendation, right? You'll see a little 3-line here. Okay, so here is where we're using our recursion. This is the base case, okay? And it's going to be same thing like before, n minus 1, because we've got to bring things backwards, right? And that's it. And the only other thing we need to do is return it to the console. So we'll test 0. Okay, so we have to call our function now. Okay. What I'm going to do is I'm going to go like this. Int n value. Okay, and I'm going to make it 0. All right. Let's pass it in to here. Okay. Take note, it's 0. Take note, it's 0, right? If n is equal to 0, return, right? Let's test that. This is all part of the learning and growing, guys and gals. Test your code, make sure it works, right? Again, as a developer, the onus is up to you to make certain that things are working great, to make certain that things aren't going to break, Okay, you actually have to test your program thousands of times, running different, maybe the same repetitive code over and over again, depending on what you're doing. And that's all part of the testing. You got to actually try to break it. You got to imagine, what would some troll do? Imagine some troll is going to use your program. Think of the troll, right? Troll logic. I know you're not a troll, but just try to imagine, get yourself in the mind of a troll. What would a troll do, right? And then you actually do you could create if-else statements. Oh, well, what if a troll decides to put in -1 or type in some words or whatever? There's ways that you could do stuff in your code to keep them from being able to do that kind of stuff. And then the joke's on them. Let's go. Okay, let's go. Let's run it. Check it out. So we're doing a print. We're just printing a string. And again, right now it's 0, so it should just return. And it did. Boom. Just went straight to return. Milliseconds fast. Done. Okay. So now I gotta pass in a value. So I could set it up. Kind of like we did before. User, please enter a non-negative integer. Okay, boom. And then we're going to store that just like we were doing before. And value, boom, boom. Okay, and there we go. Okay, boom. Right? That's taking it from being a value 0 and making, this is how we do the changes, making the magic happen under the hood. And if I don't want to make a copy, I just simply do this. I'll just kind of lead into it now. This is using an asterisk is called pass by reference. Right now, I'm passing in. We're going to talk about it. I'm also lead into it a little bit now. Right now, I'm passing a value by, or passing by value. Okay, which means it makes a copy of it. It makes a copy of this value and uses it in here. So it's duplicated. Now, if I go like this, I'll just bring it up so it's brought to your attention. Now you're aware of it. By the time we get to that specific area in the course, it's going to be like, you're going to be like, man, this is so easy. Oh, I get it. It's so easy, right? Because this is a concept that's hard for or difficult for people. But remember, your functions need to match. Okay? The declaration needs to match. Okay? So now what I'm doing here is I'm actually passing by reference. That's what it's called. And it's an alias, essentially. All right, we're going to be doing some pointer stuff, which I find passing by reference the easiest, maybe the laziest. Cannot convert into. All right, because I'm being silly because we're not inside an int function, right? But then I would have to return a value. So, anyways, I'm going to get rid of that. That's kind of a slip on my part. It has to be an int function for that to work. Silly me. Silly me. I'm all excited to show you this. And without even thinking. But now, at least now you know about it. You're aware of it. Passing by reference. Again, the function type has to match. All right? Silly me. Okay, let's build it and run that. Let's go. There we go. So I'm going to enter in 5. Let's go. And it's kind of like a for loop in the sense what we're doing there, right? Instead of using a for loop, we could have did the same thing. Did I get into for loops and that yet with you guys and gals? Probably not. But that's essentially what a for loop would do. It repeats stuff without you having to write the same line of code all the time. And as you can see here, with our function, the recursion process did all the magic under the hood,